A standard is a set of agreed-upon rules, specifications, or guidelines that define how something should be done. It acts as a benchmark for quality, performance, and consistency across industries. Standards are usually developed and approved by recognized external bodies such as ISO, IEEE, or NIST, and they often carry mandatory or regulatory weight, especially in sectors like finance, manufacturing, and information security. Example: the ISO 27001 standard defines how organizations should manage information security, while ISO 9001 sets out the framework for quality management. The purpose of standards is to ensure that products, systems, and services are reliable, effective, and safe. They create trust between businesses and customers by assuring everyone that processes meet a proven and accepted level of quality. Example: when a software vendor complies with ISO standards, clients feel confident that their data will be handled securely and that the system will perform as expected. In short, standards bring consistency, reliability, and credibility, essential ingredients for building trust and sustaining long-term business growth. Policies are the high-level statements of management's intent and direction. They set the tone for how the organization operates and makes decisions. Think of them as the constitution of governance. Everything else, like procedures and standards, flows from them. Policies must always be aligned with the organization's strategic goals and regularly reviewed to stay relevant as business and technology evolve. Example: a company's information security policy may require encryption for sensitive data. If the policy isn't updated, new technologies or cloud services might not be covered, exposing the company to risks. For auditors, the key task is to check the currency and compliance of these policies. That means confirming that they've been reviewed recently, approved by management, and communicated to all employees. The IS auditor should also verify how these policies extend to third-party vendors and outsourcers, since many organizations now depend on external providers. Example: if an insurance company outsources data hosting, the auditor must confirm that the vendor's security policy aligns with the company's own, to prevent conflicts or gaps in data protection. In summary, strong, current, and well-aligned policies provide the foundation for effective governance, guiding both internal teams and external partners toward consistent, secure, and compliant practices. An information security policy is a formal set of rules and statements that guide how an organization protects its information and technology assets. It defines management's expectations and provides direction for employees, contractors, and business partners. The policy must be approved by senior management and properly documented, communicated, and enforced. Everyone, from staff to vendors and suppliers, should understand their role in keeping information secure. Example: a bank's information security policy may require all customer data to be encrypted, prohibit personal email access on corporate systems, and mandate regular password changes. For auditors, the information security policy serves as a key reference document when performing IT audits. It provides the baseline for evaluating whether the organization's security controls are adequate and effective. The IS auditor should also review the adequacy and completeness of the policy. One way to do this is by comparing it to recognized standards like ISO 27002, which provides a global benchmark for what a comprehensive security policy should include. Policies should be reviewed at least annually, or whenever there are major changes, such as new technology, mergers, or emerging cybersecurity threats. In short, a strong and up-to-date information security policy helps ensure that security practices are consistent, compliant, and aligned with business and regulatory needs. An effective information security policy should cover several key areas to ensure that all aspects of data protection and system security are properly managed. The first is a high-level information security policy, which outlines management's overall direction, goals, and commitment to safeguarding information. It defines the organization's approach to risk, accountability, and compliance. Example: it may state that all sensitive data must be protected in line with ISO 27001 standards. Next is a data classification policy, which defines how information is categorized based on sensitivity, such as public, internal, confidential, or restricted. This helps determine how data should be stored, shared, and protected. Example: customer records might be marked as confidential, requiring encryption before being sent outside the company. The acceptable use policy defines how employees can use company IT resources, such as emails, internet access, or mobile devices. It prevents misuse that could lead to security breaches or reputational damage. An end-user computing policy covers how users manage tools like spreadsheets or databases developed outside the main IT environment, ensuring these are controlled and backed up properly. Lastly, access control policies define how users are granted, modified, and revoked access to systems. Example: access should be based on job roles, with regular reviews to remove inactive or unnecessary accounts. Together, these policies form the foundation for a strong and consistent information security framework, ensuring that everyone in the organization knows their responsibilities for protecting data and systems. Procedures are the detailed, step-by-step instructions that show how to implement an organization's policies. While policies describe what must be done, procedures explain how it should be done. They are written in a clear and easy-to-follow format so that employees can consistently carry out their duties without confusion. Procedures document both business and IT operational processes, including the controls that help reduce risk and ensure compliance. Example: a company's policy might require regular data backups. The procedure will specify how often backups should occur, where they should be stored, and who is responsible for testing recovery. Procedures are usually created by process owners, who translate management's high-level goals into practical, repeatable actions. For IS auditors, reviewing procedures is a key step. They check whether controls embedded in these procedures are well-designed, efficient, and capable of achieving the intended objectives. Example: during a system access audit, the auditor may review the user access creation procedure to ensure that approvals, documentation, and periodic reviews are properly defined and followed. If there's a gap between documented procedures and actual practices, or if no written procedures exist, it becomes difficult for both management and auditors to verify whether controls are consistently operating. In summary, well-documented and properly followed procedures ensure clarity, consistency, and accountability, forming the bridge between policy intent and day-to-day operational control. Guidelines are supportive documents that help employees and teams understand how to apply policies, standards, and procedures in real-life situations. They don't set mandatory rules, but instead provide helpful advice, explanations, and examples to make implementation easier and more consistent. Guidelines often include clarifications of policies, step-by-step examples, best practices, or useful tools that staff can use when performing their duties. Example: if a procedure states that sensitive data must be encrypted, the guideline might explain which encryption tools to use, how to handle encryption keys, and examples of secure file sharing methods. They may also include background information about why certain controls exist, helping employees understand the reason behind a security rule, which improves compliance and awareness. Example: a password management guideline may explain why complex passwords are required, offer examples of strong passwords, and suggest using a password manager tool. While guidelines are not mandatory like standards or procedures, they are a valuable part of information security governance because they make compliance more practical, user-friendly, and consistent across departments. In short, guidelines bridge the gap between theory and practice, helping staff follow policies correctly, understand their purpose, and apply them effectively in their daily work. Several internationally recognized IT frameworks help organizations manage, secure, and govern their information systems effectively. Each one serves a different purpose, but together, they form a strong foundation for IT governance, risk management, and compliance. Let's look at the main ones. COBIT, a comprehensive framework for governance and management of enterprise IT. It helps align IT goals with business objectives and defines control practices auditors can use to assess performance and compliance. Example: used by auditors to assess whether IT processes are properly controlled and delivering business value. ISO/IEC 27000 series focuses on information security management. It defines how to build, maintain, and continuously improve an organization's information security management system, ISMS. Example: ISO 27001 certification demonstrates that a company protects customer data effectively. ITIL, Information Technology Infrastructure Library, provides best practices for IT service management, ITSM, focusing on delivering quality IT services that meet business needs. Example: helps help desk teams manage incidents, changes, and service requests efficiently. OISM-3, Open Information Security Maturity Model, a model that measures the maturity and effectiveness of security processes in an organization. ISO/IEC 38500-2015, defines principles for corporate governance of IT, guiding boards and senior executives on how to direct and control technology use. ISO/IEC 2000, the global standard for IT service management, aligned with ITIL principles, ensuring consistent, reliable service delivery. ISO 31000-2018 provides risk management guidelines for identifying, assessing, and managing organizational risks, both IT and non-IT. In summary, these frameworks help organizations achieve accountability, consistency, and continuous improvement in how they manage and secure technology, while giving auditors a solid foundation for evaluation and assurance. Several internationally recognized IT frameworks help organizations manage, secure, and govern their information systems effectively. Each one serves a different purpose, but together they form a strong foundation for IT governance, risk management, and compliance. Let's look at the main ones. COBIT, a comprehensive framework for governance and management of enterprise IT. It helps align IT goals with business objectives and defines control practices auditors can use to assess performance and compliance. Example: used by auditors to assess whether IT processes are properly controlled and delivering business value. ISO/IEC 27000 series focuses on information security management. It defines how to build, maintain, and continuously improve an organization's information security management system, ISMS. Example: ISO 27001 certification demonstrates that a company protects customer data effectively. To keep IT and business processes efficient, consistent, and effective, organizations need to use a process maturity framework. These frameworks help measure how well a process is defined, managed, and continuously improved over time. Two well-known models used for this are the Capability Maturity Model Integration, CMMI, and the IDEAL model, which stands for Initiating, Diagnosing, Establishing, Acting, and Learning. The CMMI framework provides a step-by-step path for process improvement, moving from ad hoc or chaotic processes to fully optimized and continuously improving ones. Example: a software company using CMMI Level 3 ensures all projects follow the same standard development and testing procedures, improving reliability and quality. The IDEAL model focuses on a cycle of continuous improvement. It starts by identifying areas that need change, diagnosing, developing plans, establishing, implementing improvements, acting, and learning from results, learning, to strengthen future processes. Example: in an insurance firm, IDEAL might be used to improve claims handling, analyzing delays, setting new steps, applying them, and reviewing progress quarterly. By applying these frameworks, organizations can measure progress, reduce errors, and build a culture of ongoing process improvement. This consistency ensures that operations remain effective and aligned with business goals, even as technology or personnel change. The Capability Maturity Model Integration, CMMI, helps organizations measure how well their processes are managed, controlled, and continuously improved. It has 6 maturity levels, from 0 to 5, each showing how structured and effective the organization's processes are. Let's walk through each level. Level 0, incomplete. At this level, there's no consistent process in place. Activities happen randomly or reactively. Success depends on individuals, not systems. Example: a small IT unit fixing issues only when they occur, with no documentation or repeatable steps. Level 1, initial intuitive. Processes exist but are unorganized and vary across teams. There's little control or planning. Example: a company where project management depends on personal experience, not standardized procedures. Level 2, performed. The process achieves its goal using a basic and repeatable set of activities. Things start to become consistent. Example: teams begin using documented steps for software updates or incident handling. Level 3, defined. Processes are standardized and documented across the organization. Everyone follows the same procedures. Example: change management policies are defined company-wide and approved by management. Level 4, managed. Processes are measured and monitored using data. Performance is predictable and tracked. Example: the IT department tracks average downtime, ticket response time, and other KPIs to improve service. Level 5, optimizing. The process is not just managed, but continuously improved using performance data and feedback. Example: after analyzing incident trends, IT automates routine fixes to reduce manual work and errors. In short, as organizations move from level 0 to level 5, they move from reactive and informal processes to structured, measurable, and continuously improving ones. A true sign of maturity in IT governance and management. The ideal model is a structured framework developed by the Software Engineering Institute, SEI, at Carnegie Mellon University to help organizations improve their software development and IT processes in a systematic way. It stands for initiating, diagnosing, establishing, acting, and learning, and it provides a step-by-step roadmap for planning, implementing, and sustaining process improvements. Let's break it down. Initiating. It builds commitment and prepare the organization for improvement. Example: management approves a plan to improve software delivery timelines. Diagnosing. It assesses current practices and identify gaps or weaknesses. Example: the team discovers that lack of testing standards is causing frequent production issues. Establishing. It develops action plans and set clear goals for change. Example: the IT department creates a standardized testing framework and assigns roles. Acting. It implements and monitors the improvement actions. Example: teams begin using automated testing tools and track quality metrics. Learning. It evaluates outcomes, captures lessons learned, and makes continuous improvements. Example: after implementation, feedback is gathered and the process is refined for the next development cycle. The ideal model helps organizations create a culture of continuous improvement, reducing rework, improving quality, and ensuring that process changes deliver measurable business value over time.